All right. Yes, you can see it at home. Yeah. So, fair for whom? Indeed, as Matthijs introduced, my name is Johan van Zus. My background is in medical informatics, University of Amsterdam. I think a few months ago we had also a speaker from there, Ronald Cornet. I did my PhD here in Maastricht, actually at Clinical Data Science Research Group, back then still at Maastro, or physically actually at Maastro, at the Department of Radiotherapy. As Matthijs mentioned, several affiliations currently at BIS, right? It's for Smart Digital Society and Clinical Data Science Research Group. So what I'm going to talk about today is, well, first a little bit fair principles and practices. So as Matthijs already started about, but maybe repeating something, maybe I was going to do that. And then, yes, but that's fine. But how do we make data more fair? And why I would say deliberately more fair, not making data fair, but more fair. Also, a little bit about fair for AI, and what does fair mean for AI, and probably in a different context as what you're thinking about now. And afterwards, round up, and then probably I have time for questions. So let's start. Fair principles and practices. I don't need to repeat this slide from the 2016 paper, but I still include it. So we have all the fair principles. But if you read the article carefully, there's one sentence in there which strikes me the most, or part of the sentence. The fair principles provide steps along a path toward machine actionability, which basically means steps along a path. Doesn't mean basically that you always get fair data. It means you get more fair data, right? Because where does the path end? That's the question still, right? And towards machine actionability. And it basically means that machines can work with data instead of only humans, right? If we write text, maybe that changed now in the last few months with ChatGPT, but and GPT kind of algorithms. But think about it: the computer needs to be able to do something with the data instead of the human. Because if the computer can do something with the data, we can always make a human representation of the data, right? Instead of starting with human data and then afterwards having to think about technical representation. So fair data to me is more, how do we get more and more towards this machine actionability, right? That the computer can work with this data, and that's primarily for a computer and secondary for a human, because we can generate that human perspective to it. Not only just for the sake of creating fair data, but actually to use that data, right? Because otherwise, why would we make data more fair and spend time and effort in it? And I'll come back to it a little bit later. And what we've seen also is that there are now many different metrics and tools, and Sheldon J presented it here as well some time ago, how to evaluate how fair someone is, right? And whether they adhere to many different components in those fair descriptions, which they then unravel into different kind of specific criteria data needs to adhere to, right? But if you look carefully at those descriptions, you can ask many different questions. So if you would have the simple one of, I think it's F1, that you need to have unique, persistent identifiers. What does it actually mean, right? Because uniqueness of a URI, how can you guarantee that? Basically by knowing that that URI cannot be used by someone else because you're in full control and you have the processes actually in place to make sure that no one else can claim that same URI, right? Because otherwise it's not unique. But there's work to do on the back end to make sure it's unique actually. The same holds for persistence of a URI. If we talk about persistence, what do we actually mean? We can check an automated check if that URI exists and there's data on the URI that we can fetch. But how do we measure that a URI is persistent, right? We can check that it exists and that there's data, but how to make sure that it's persistent. And then you can say, well, if you go to PURL or Zenodo or these things, because they guarantee that's going to be persistent, that's fine. That means those organizations have to exist for a very long time and that you're relying on that. But what if I would say, I've got my personal domain and I'm claiming myself that this URI is persistent because I'm going to take control and maintain that for the rest of the time, right? Now, those validation tools will say, or can say, well, I don't know that in my list of schemas of persistence, so therefore I don't know whether it's persistent, flag it as dubious, right? So the question is, how do you measure these kind of things? And therefore, what's then, what are we actually measuring and evaluating here? But let's not go into detail there. These evaluations are still useful, of course, because you want to make sure that you adhere to some kind of standard. But they're actually, for software developers, I would say unit tests. You test that something adheres to certain principles and implementations actually of those principles. Not the principles itself, but the implementations of those principles. That's what you're adhering to. And basically, that's fine as a unit test intermediate, but actually the proof is in the pudding. Basically, you want to use or reuse that fair data, because that actually means that the data was fair enough for your purpose that you want to use it. Right? Yeah. And it also means that a perfect score on a certain metric or evaluation does not mean that the data set is massively being reused, because it might be a very small niche. So making fair data doesn't mean by definition that this data is going to be reused many different times. It fully depends on the scope and context what you want to achieve with that. So in another way to see it more from a schematic perspective, we do a lot of data collection, right? In hospitals, outside of hospitals, wherever we're creating and generating data. And actually we want to use or reuse data. And what we do is we store data somewhere in the collection process, and in the use process, use that data. However, how fair that data needs to be is actually heavily influenced by this feedback loop, right? Because the use actually says what you want to do with the data. And we can make data as clear as possible for future reuse, but we can do that only to a certain extent. We can't say, in 20 years, we're going to use this data this way. Maybe if you have technology roadmap for tools where you want to use the data, but then you have a feedback loop already here. But for some data, you can't imagine how it's going to be used in the future. So you can make it as fair as possible, but it doesn't mean that in the future it's going to be fair as well, or that you still need to do additional work to make it fair again and for it to use for new information. That's more or less our take on it, and specifically the use and reuse. How are we using and reusing the data actually? Well, in our research group, mostly in the federated learning context, right? Where we're trying to keep the data inside of the hospitals. For example, this is a very regional example. It's a very old example. We're doing it now on a much larger scale worldwide. But it basically means we're sending the analysis to the hospital, calculate the analysis result over there, and only send the analysis results back to the researcher. But basically what we're doing here is we're actually blindfolding the researcher, right? Because he or she cannot see data anymore. It has to rely on schema descriptions, definitions of data, semantics, which basically means we need to have, especially the I in terms of interoperability of fair data, the R for use or reuse, because we're reusing clinical data. We have the A, accessible. How do we access data? Well, we don't physically access that as a researcher, but we're sending the analysis which accesses the data. And findable is more or less in this infrastructure of hospitals available. I'll come back on that a little bit later as well. So what you see here is how we implement FAIR principles is actually to be able to reuse the data to train machine learning models, deep learning models on image recognition, and therefore need that FAIR descriptions, because otherwise we don't know what every hospital needs with their data and what that data actually represents. So this is basically a little bit sketching the context and rationale why we're doing this. But how to make that data fair, and how do we do that? And this is a little bit our hypothesis and the work we're doing now. Traditionally, we can say we have a data source on the left. We use an ETL tool pipeline, and on the right, we have our fair data. That's a very specific view of what we're doing in there. However, there are certain things in question there. Someone needs to make that ETL pipeline, right? And that person actually needs to team up with a clinician to make sure that the data which is in here, which the clinician actually knows, because he's the main expert, needs to make sure that that ETL pipeline is being generated using, for example, R2RML scripts or any other ETL pipeline that you're using or scripts that you're using for that, or even just plain Python scripts. And that in that target, you validate again the, let's say, technical person plus the doctor or the main expert, that this data actually represents what you really need, right? And to be honest, this process is a tedious process where many times back and forth, the doctor and the technical person or the domain expert that is said, and the technical person are going back and forth, hey, what do you mean with this column? What does this actually mean? Along the process of building this script, which basically means that it's a very, let's say, time-intensive process for both parties, right? Time-intensive in terms of you need to catch that person again, ask that question, okay, we're continuing. Maybe you ask this two following questions again and continue to write the script. Test the script, evaluate, no, this is wrong. Okay, go back to developing the pipeline. It's basically a messy process. Second, if we do this with hospitals worldwide, it's such a federated learning concept, and we're using our ETL tool based on R2RML, then we're dependent on the knowledge and technical skills that technical person has on these technologies, right? And understanding the target format, but also understanding how to build those scripts. And what we see there often is that they know ETL, know SQL, or these kind of things. But then if we're coming in with R2RML or specific toolkits, then it's like, oh, yes, it takes time to teach them. And if you come back a half year or a year later, that's like, oh, that knowledge is gone or forgotten, and you have to re-explain it again. Right? So this whole process, this whole ETL process is a little bit messy and is a very tedious job and lots of work actually. So there are several issues. The technical person does not know in-depth domain knowledge, right? So it means back and forth between the domain expert, for example, a doctor, and a technical expert. It also means technical person does not know in-depth knowledge about the target. Sometimes, are we going for OMAP? Are we going for a knowledge graph? Are we going for what kind of representation and terminology is being used? So there is also that technical person has a learning curve for target representation and the technologies being used, maybe. And the output is far from the expertise of the domain expert. So how do we assess whether that result actually represents what we actually mean in terms of fair data, and if we have correctly converted those data sources? So we're actually proposing a different way of ETL process. And how we're doing that is if we have the source on the left and the target on the right, we're actually first describing high-level metadata in terms of who curated this data set, all the core basic properties of that specific data set. And then afterwards, we let the domain expert annotate that specific data set. So annotate meaning saying this column means gender. And if you know that it's gender, the value 0 means male and the value 2 means female, for example. And also, if there's a date column in there, identifying to which variable that date belongs. Because it might be the date of diagnosis, and we have a diagnosis column and a date column, but the computer doesn't know how to relate them to each other unless we explicitly mention that, right? So we let them annotate all these different features and elements in the data set. We don't change the source structure, actually. We just let them annotate the data set. And then afterwards, if needed, the technical person has the information about what does this data actually mean, and maybe can gather it for several data sets, and do the actual transformation of the schema. So we're separating actually the logic of the semantic annotation, what does this data mean, compared to that syntactic difference and structure conversion of your data structure, which basically means we disentangle this problem of, hey, what does this mean? Can you look at this? Because this part is something the clinician can assess and evaluate if things are correct. This part is purely for the more data-oriented and technical person. Then, for specific projects, we need to identify how do we do this, right? Which terminologies are we using? And which values are allowed in there, yes or no, these kind of things. And that's what we're putting in there using the FAIR implementation profiles, where we use a reference to the CEDAR template to specify this is the high-level metadata you need to describe for your data set in a specific context for a specific project. And using, well, this gets a little more technical, but SHACL descriptions to describe which semantic values are allowed to be used there and which do we really need to do this analysis. And then afterwards, we can also use the SHACL file to validate whether that transformation was successful in the end, and to make sure that that data consistency is there when we are asking for a project. This is from the theory perspective. Does it work? Well, on the technical level, we've done these tasks, and we left deliberately out this task. We did these tasks in the domain of head and neck cancer, where we had several data sets and annotated, and all of them were CSV format. And so just one table in tabular format, where we annotated the column ID is actually equivalent to the patient identifier. And the column gender is actually equivalent to this NCIT code. And also, if we know this is gender, then we could say if the value is V, female in this case, then we say we build a reasoning rule actually to state that if we have an instance of gender and the value is V, then actually it's also an instance of female. And in this way, building these reasoning rules means we can annotate the data and basically can create or reason to generate views on a data set with these existing terminologies. What's then an advantage there is the question then becomes, what's now the added value of having a uniform schema? And if we all have the same schema, which is a two-dimensional table where every row is a patient, right? Then you can actually do an analysis on 1, 2, 3, 4, 5 data sets where we just send one query to all these 5 data sets using patient identifier and gender and female and male to fetch the data as if you would have one data set, right? Because if all of these nodes have reasoning enabled, have these reasoning rules in place to define those equivalences, then basically we can query it as having one data set. And that's what we actually proved and shown, that we can do that in a centralized context, where we centralize several data sets, but actually we can do this also in a federated context, where every data set is stored on a different location physically somewhere around the globe. So meaning the part of annotation is very important. And if everyone has that same schema already, which maybe is the output of SPSS or a CSV file, what they got from their data, the business intelligence department or whatever, then if everyone has that same schema, why transform it? And you can always do that at a later stage if needed. So how does this system work in practice? Because this is very technical. Well, we actually made a front-end tool for the more domain experts where they can use it. And this is a small video or demo of that. So for example, you have a data set, and in this case it's a CSV data set of patients regarding dementia. You see that there are a lot of variables in here. And you have APU and sex and date of birth 0, education 0, APU 4. Well, what are all these different kinds of variables? Well, then we say people can download and install our application. At the moment, this download and install means downloading it from GitHub and then running it. We're working to improve that. Let's go a little bit further. And if they start the tool, which is a web-based user interface, then they can say, what's my fair implementation profile? Which project am I involved in? So they enter the URL of that description of variables they need to adhere to. And then say, okay, load that information, load that fair implementation profile. You see here, we have now the EPND common data model with this CDR template and this Jekyll file description. And from there, they can say, okay, I have a data set and I'm gonna report on what I have. So they click add, they add title of the data set or the DCAT descriptions they have to find in that CDR template. So this is fully customizable per project for what you want to report on that data set descriptions. And if they fill in all this information, then, button, and save that, here we go, then they get a new forward. And they click on it and then say, okay, here's all the information I filled in that questionnaire field. Who's the owner? When was the data set issued? Where was it based on? You name it. What's the title of the project? You name it. And then they can say, okay, now I'm going to add my data set to it. So they click add, they upload their CSV file, for example, or they link it to their database. We have here an example data set there. And afterwards, what they can do is they've uploaded the data set, gets an identifier for the data set, and then they can start annotating the data set. Yes. So what do? They select a column from their data set, in this case, column name, sex. They look up from our definitions, what is it? In this case, the gender finding. And afterwards, the UI is still clunky. They can go into, okay, first we also identify a different column, that's fine. It's a video. Yes, duration of formal education, and so on. Check. And then afterwards, they can go into defining what does 1 and 2, in this case, mean, male and female. So they can look up what is actually the SNOMED definition of gender finding, but they can also, in their own tool, then afterwards identify what male and female is. Yes, so it's modify, and then it's pre-populated from that fair implementation profile, the options which are then listed for its specific variable. So they can click what's now male, what's now female, and continue, and store all that information. They can map it for many different columns. Oh, no, I'm skipping. They can map it for many different columns, and afterwards get a data set which then adheres basically to those definitions and export that with those terminology concepts rather than local terms. It's also in the video, but it's a little bit later. For sake of time, I'm continuing a little bit on there. So I think this one is not linked to Power Hour. So if you can borrow yours, yeah. Who's missing? Yeah. So what are we currently doing with that tool? We've developed the tool, but now first of all, does this actually help the clinicians to make sure that this is more efficient, right? So we're actually evaluating that fair annotator to see, does it improve the overall time of generating fair data? I think the output is just not connected. So does it help them in that frustration process of going back and forth several times, right? And does that help our hypothesis that we can split those two roles and responsibilities, managing and converting the data? Second, how easy to use and understand. Is it for non-technical people? Well, technical people think like, yes, this user interface looks good, perfect, but a doctor or a domain expert might think completely different. And last, how does it compare to other verification tools? Are other tools better at that, or don't they split those different roles? And therefore, is our tool actually improving it or not? And how does it compare? So we're actually comparing that at the moment in one of the research projects. The other challenge of current work is the generation of input data, specifically those fair implementation profiles, how to generate them, who should generate them, who has the right knowledge to build them. Second, with the CEDAR templates, and specifically also the Shekel files, because here it gets more and more technical. So you need someone in that project who's technical enough to build those descriptions about which information elements we need, and how to represent them, and what are now the right terminology terms that we're using for all these different concepts. This is work that needs to be done, but the advantage is you do one time per project instead of every hospital reinventing the wheel of what term they're going to use for a specific project. And last, ease of deployment. As I mentioned already, currently it's go to this Git application, download these files, and run them on your computer. We can't sell that to, let's say, doctors or maybe domain experts. We need to have something where they go to as a web page or something else that they can just readily use it. So we're looking which do we need to, if the evaluation turns out that this works, then we need to work on the easy to use tools, right? Because otherwise it's also a waste of effort to first do this part before we know that this is actually a more efficient process. So that's on fair data. But what about FAIR for AI? And if we talk about FAIR for AI, we usually think about how can AI make use of FAIR data. But an AI model itself is data as well, right? Because these are covariate weights of a specific model or a deep learning model, and are basically numerical data which we store on a computer, right? But then the interesting thing is, how do we actually work with AI models in a science domain? Well, this paradigm we had about data, new data is being collected, extracted, analyzed, publication, and afterwards we throw away the data. That's what we try to overcome with FAIR data and FAIR principles. But we can actually apply this also to AI models. Because as researchers, what we do, we build an AI model, we publish about it, and then afterwards think, we're done, next, right? Or let's collect new data sets to improve the model, publish it, and go to the next project, right? But actually, there's a whole gray area of getting these models then actually into clinical practice. And we see this happening a lot, also, for example, in COVID-19. So here from Maastricht, actually, a large research group analyzed, and there's an ongoing live review actually, of prediction models for COVID-19. But one of the conclusions I found most interesting is that they say this review indicates almost all published prediction models are poorly reported and are at high risk of bias, such that their reported performance is probably optimistic. And if you read carefully the paper, what they say, they did literature review, found 169 studies describing 232 prediction models. And if you then look carefully a little bit further in this conclusion, they only said that 2 prediction models, actually after the yellow part, however, we have identified 2, one diagnostic and one prognostic, promising models that should soon be validated in multiple cohorts. So out of these 232, there are only 2 prediction models which actually make sense to be used in clinical practice at some point in time. But first, external validation in multiple cohorts needs to be done. Right? Thinking about that, what are we actually doing with AI models? Because we're stacking them basically now in scientific literature, where people need to figure out from the literature again, what is this AI model doing? And hopefully they have a GitHub repository where they store the code, but that's also sometimes in this. From the literature, we need to make those models digital again, while they were digital before. Then we need to do a quality assessment of the model inside the hospital to make sure that we get the same performance as they described in the article. And afterwards, we only can implement it in clinical systems or decision support systems, right? So there's a whole trajectory still needed before we can actually apply these AI models in practice, which led us to the idea of why not make fair descriptions of AI models themselves, right? So why not make descriptions stating what is now that fair AI model or that fair service? Store these definitions of these descriptions, and then afterwards be able in a hospital to download them, these descriptions, therefore also the models in the end, validate that in your own data set within your hospital, and if the validation report then says this is safe to be used in clinical practice, then apply that in your clinic, right? And give it out to doctors. But then also have a workflow in place to continuously check that, because there might be data drift, there might be model drift, there might be all kinds of drift that you need to have that AI model be checked continuously. And this is what we're doing in this project, or multiple projects around the webpage fairmodels.org, where we are building a decentralized database, let's say, of these AI models. So there's no central location where we store the AIs or the description of the AI models, but it's only one large index of where all these different models can be found. So we're storing one centralized index. Everyone can read that index and then follow the references to where the descriptions of these AI models are stored. Which basically means everyone can keep control of their own AI and publish maybe the metadata, but not the AI model itself, or maybe publish them both. That's up to them. We don't decide on that. But we're giving them tools to do this. And actually, we built software for that to actually store these models there, but then also for users to search the model, identify data, or identify which models are actually useful for me, that people can download the model and see, first of all, the model heuristics. Do they have all the input features which are needed to run this AI, for example? Or do I have similar distributions as what the AI was reported to train on, that you have some idea, is it actually going to work in my hospital, in my clinical setting, or in my setting where I want to use it? Then afterwards, you can go for model performance. Now I download the model, run it locally, or run it at the servers where it's located, test out what the model performance is, and then afterwards report that. And if you're happy with that, maybe also use it in clinical practice, but also publish and upload the report back. Why do we have this feedback loop there? Because then we can also generate an overview of which AI models have been validated by different hospitals, what are the characteristics of these different hospitals, and how good was the performance of these models. Instead of giving 3 or 4 likes, I like this model, do it based on their actual performance and the descriptions of these hospitals and the population of patients they have in these hospitals and so on, which gives a more, let's say, transparent view of what this model is like. So we've actually plotted this out and actually have tools to generate this. So if we have a model specification, we can make a validation. So this all goes back into the data. From that validation request, we can publish baseline characteristics about specific input and output variables. So say what's the mean, min, max, counts, all the usual things that you get if you use summary in Python, I would say. But also from the validation metrics. So we can say on how many patients was this model evaluated, what was the AUC, area under the curve for that execution of validation. What was the bias score, the mean squared error in there? but also to regenerate the AUC curve, the information, and also for the performance default curve, to give all that information and to store it back, that people can actually see what was the evaluation for one specific validation. Because this you can also multiply several times in the future, right, with more patients with different data in different hospitals, but all linked back to a specific model so that we can find out what is now different performance in all these different models. So that's actually where I'm going to wrap up more or less, and basically have several take-home messages. Fair guiding principles are applicable to both data and software if you see AI as being software, right? It's not purely that we say it needs to be findable data, but you can also say it should be findable, accessible, interoperable, and reusable software or AI, right? There's also RDA working groups on fair software, but also fair AI models. Second, making data more fair might consist of different processes for specific scenarios. How you make data fair in a hospital setting with a clinician and a more technical person, as shown before, might be different from what I just presented with Fair for AI, because you can automate many different steps in there, right? So the fair descriptions for AI models might have a completely different workflow and process that the AI researcher is more easy to work with and more technical to work with than what you're doing in clinical with clinical data and hospitals and doctors, right? And third, when making data more fair, apply to the specific reuse case or a use case. Because in the end, we can evaluate the models or the fair data, but actually the reuse is the actual thing where you're doing it for. So try to incorporate if you're doing a project regarding making data more fair, to actually bind it to a use case that is actually reused. So with that, I'm at the end, and want to thank you for your attention. Yeah, if there are questions, I'm happy to answer. Yes, are there any questions?
So this morning, I found out there's a model where you can sing a song, and then a model runs on your song, and then poof, it's Kanye West who's singing. So this just reminded me of like how AI is redefining what machine actionable data is, right? So how far along do you think we are with just having a lab journal, a manuscript or a paper, a data vocabulary in a Word document, and then combine that with the data sets of variables and values, and we don't need a verification pipeline anymore. It's set, it's already done.
Yeah, I see the question, and there's of course a lot going on with all the large language models and advanced models going on now. I think it fully depends on what is the risk of the output, right? And what you see now, there's a lot of discussion about the ethics of GPT algorithms and large language models, and for this one as well, because you can make fake audio clips, fake videos, whatever, right? That goes more into the ethical and societal aspect. What do we allow? For what purposes do we allow it, right? But there we actually say, well, we accept inherently on the technical side that there might be errors in those models, right? While in the healthcare domain, the question is, do we accept errors in that model? And how is the model being used, actually, right? And especially that latter question informs a little bit about how strict you need to make the validation. Because, for example, a algorithm which is based, a deep learning algorithm for auto-contouring on organs, there you might say, well, if it's not the perfect contour, it doesn't matter. If it saves time for the clinician because he doesn't need to spend 2 hours delineating tissues and organs and things, but it saves him time and he can correct it still before applying it, that contour in practice, is different from we're now predicting what the outcome is of a certain treatment. There you want to be as sure as possible, and what are the side effects of a given treatment, right? So it fully depends on whether the human is in the loop, whether the human is on the loop, these kind of concepts basically, combined with the ethical and societal aspects regarding use of AI.
Yeah, I think if I look at like that paper you mentioned, where there's only 2 models that are viable in the clinic, I think we are then holding ChatGPT or whatever model that will do this verification trick maybe to a higher standard than we are currently doing in practice. But yeah, I see the point.
It fully depends on the intent and purpose what you want to do with that one.
Yeah. Any other questions?
Chat? Sure.
Okay. Well, then I have another one, and I want to ask a question. So you mentioned this verification and preparing the data, curation of the data is a very tedious and, yeah, I always say like it's not a very sexy job, but it's very important and it needs to be done. I think it's also undervaluated. I had a talk with some other people who made verification pipelines, and they had sort of the same idea. Should the verification to properly appreciate it and to make sure that there's enough time and money for that, should it be part of the architecture, the data architecture that people are using, especially like for federated learning? Should it be a part of the costs? Should it be part? Should the architecture do the verification, or do you think that will not be viable? We always need the domain experts there, like the people who own the data and not domain experts in the same field, but who do not own the data, who haven't created the data.
I think it's targeting several elements there, right? Because the question is, does the domain expert always need to be there? And how do we, if we say, in the infrastructure tools, thinking from a technical perspective, right? What there I think needs to happen, you see that the change is coming slightly, is you need to be agile towards your target, right? Because data representation is some kind of language, right? It's a language the computer can interpret, but it's still a language, right? Which basically means, and we know that language is going to change over time. And we see that the data representation as well. We had HL7 version 2, HL7 version 3, HL7 Fire on the clinical side. Then in the research domain, we have OMAP as a large player, but there we also have CDISC for clinical trials and so on. And if you see that as language and where the syntax is or the grammar, and you have then the vocabulary, which are terminologies, that's still going to change over time, because new clinical insights say like these terms should be split, or technical insights say we should split this data or store it in a different manner, which is more efficient. So this is always going to change. So in terms of infrastructure, yes, that's going to change, right? And we need to have systems which are as agile as possible to accommodate for those different scenarios. But what is the role of the clinician in there? I think it's more on the front end to identify what does this data actually mean from my perspective, right? And they can help with that part. And we might do automated things in the future that we say, oh, if you before said gender, as the easy example, is this SNOMED code, now something changed and we now have 19 different versions of gender, how do we now need to map that data to this new definition? And it might be that to say, well, then we need to go back in the data because this is a more granular definition, and we need to go back really in the data, and if we don't have it, then we can't change it, but if we have it, we should recode it, right? So it fully depends on the whole scenario, how much the involvement is, but I would say don't frustrate them with all the technical stuff in terms of schema conversions, what's the right schema to use, these kinds of things. Only have them there to define what is the actual data, or what is the data actually representing.
Okay, thank you. Any other questions online or here in the room? Okay, then I think we can conclude this session of the coffee lectures. Thank you all for joining. We would very much appreciate it if you could fill out the form I put in the chat. And the next session is, I'm not sure what the exact date.
24th May.
24th of May, thank you, Shashank. And we will have Gijs van Dijk, who is a professor of law, talking about FAIR and the law domain. So that might be very interesting. Okay, thank you all. Have a nice day.
Thank you. Bye-bye. For people here, please take some food.